Hi everyone, welcome to the TBR Webinar series. Today, Senior Strategy Consultant and Principal Analyst Geoff Woollacott, Analyst Stephanie Long, and Research Analyst Catie Merrill will be discussing the pendulum swings, customer demands, reshape how infrastructure vendors do business. Before we get started, a few housekeeping notes. At the bottom of your screens, you can access the slides, audio controls, Q&A, speaker bios, and our survey. After the webinar, you will receive an email with a replay link as well as a link to view and register for other TBR webinars. If you have any questions for us, please submit them via the Q&A widget in On24. You may also reach out to us after the event at webinars@tbri.com. Thank you again for joining us, and here's Geoff to begin the webinar, or Stephanie.
Yep. So thanks for joining today. So today we're going to talk about some of the trends we see emerging that will impact the data center market during 2019. And the team on the phone today, as Sarah mentioned, is myself, Stephanie Long. I'm a data center analyst here at TBR. And I'm also joined by Catie Merrill, who works on our cloud team, and Geoff Woollacott, who is a principal analyst here at TBR and is sort of our knowledge catch-all at the company. So this slide shows a preview of the overall themes we're going to talk about today. First is the evolution of partnerships to enable vendors to rapidly address customers' emerging demands. Then the ongoing desire by customers to work with fewer vendors as resources are increasingly squeezed, followed by the emerging capabilities that are going to impact the data center market in 2019 and beyond. And finally, we'll provide you with a brief glimpse into some of the research we're doing in the quantum computing space. Okay, so our first prediction is that there will be a shift in how vendors partner in 2019 to support rapid portfolio shifts and address growing demand for things like the cloud, AI, ML, and the result of digital transformation. And in 2018, there began an increase in cooperative relationships in the data center space that we think is going to increase in 2019. There are in general two types of cooperative relationships that we're seeing emerge more often. One where unlikely partners blend portfolios together to fill in gaps, and the other where vendors work with potential competitors to increase revenue and higher margin capabilities within a larger portfolio. And these are typically at the expense of some of the hardware deals, as hardware tends to be the lower margin piece of the puzzle, so software is emphasized in some of these instances. Okay, so the first partnership I want to talk about is Lenovo and NetApp's relationship, and it's an example of the first type of cooperative relationship. We have two relatively smaller companies that are working together through an OEM agreement to take on market behemoths such as Dell EMC, which has the economies of scale and supply chain efficiencies on its side. And so by working together, Lenovo and NetApp benefit from expanding their customer bases. They also formed a joint venture in China for storage products. This is a strategic way for companies struggling simply because they are smaller to boost their customer base and enables them to take advantage of economies of scale and turn a larger profit. And it's important to note that while supply chain efficiencies alone will not help struggling hardware vendors, it is a key aspect of it. Services investments are proving to be essential as well, as customers are increasingly desiring to receive their hardware, software, and services from a single vendor, in part to overcome the skills gap that IT is facing. So the next partnership I wanted to talk about is Dell Technologies and how they handle VMware, which is an example of the second type of co-opetition we're seeing. So VMware, as you all know, is part of Dell Technologies, which is vendor agnostic when it comes to hardware. And although Dell Technologies is embracing its better together mantra with customers, so encouraging them to work with Dell EMC and VMware together, customers are still able to work with their preferred hardware vendor of choice with these VMware deals, which in some cases could be to the detriment of Dell EMC hardware. But this benefits Dell Technologies overall, as VMware is the higher margin deal with their software components. So the vendor will encourage these deals, even if it might in some cases negatively reflect on their own hardware. And the last relationship I wanted to talk about is IBM's pending acquisition of Red Hat, which we think is likely to follow a similar pattern to that of Dell Technologies and VMware, with IBM potentially embracing some cloud rivals like AWS and Google Cloud, which currently have a partnership with Red Hat. And they might do this, again, to boost their higher margin portfolio pieces, which may hinder their hardware assets in the long run. So during 2019, we think that more niche infrastructure vendors will follow suit with these cooperative partnership tactics to remain afloat, especially as commoditization hinders profits and customers increasingly move toward cloud-centric architectures. And another driver of these type of partnerships we think will emerge is newer technologies such as quantum computing. So in this space, there are a lot of vendors playing right now with some clear leaders such as IBM. But as the technology becomes more mature, we think that some of these smaller companies may partner or combine to take on the larger vendors in this space as well. And with that, I will turn it over to Katie.
Great, thank you, Stephanie. So now I'll segue into our second prediction, which looks at how customers are going to look to vendors to become one-stop infrastructure shops. And really, infrastructure vendors are going to look to services in order to capture these customers and land sales opportunities. So just to put some context around that, a trend that we're really seeing evolve in the IT sector is a lack of hard skills. More specifically, there's a really wide skills gap that resides between IT departments and newer technologies. And this is pushing IT vendors to seek out, hyper-converged infrastructure, for example, as well as the cloud, due to less maintenance requirements. In terms of the cloud, a lot of companies have drastically reduced their IT staff because years ago they assumed that cloud would automate. However, of course, now we're seeing that's not the case, and there's a lot of integration challenges that IT departments hadn't anticipated. And from a cost perspective, what we're finding is that the majority of the CIO budget is allocated toward infrastructure maintenance versus something much more meaningful like innovation. So this kind of highlights that there's definitely a gap there. And to put some context around that, I was just going to pull some data from TBR's Hyperconverged Platforms Customer Research Study that was recently published. What we found in that study was 19% of respondents are cutting their spending in order to fund hyperconverged infrastructure, keeping in mind that the majority of these cuts are residing within hardware. And then 72% of respondents are maintaining their budget in addition to investing in HCI. So this underscores that there is a wide gap and vendors are heavily investing in training to fill it. As an example, IBM recently launched a new apprenticeship program as a way to train employees rather than hiring outside talent because of how difficult it is to find these pre-trained workers. Now, to take that one step further, many businesses that adopt these newer technologies, take hyperconverged, for example, will then seek out service providers for even less maintenance requirements. And again, from our customer research, we found 60% of hyperconverged customers are buying maintenance and break-fix services. So these companies that are trying to play catch-up in terms of emerging technologies are generally operating outside their expertise, and therefore look to services-centric vendors to kind of supplement them in the digital transformation process that we're hearing so much about. As an example, I want to pull the HPE and Accenture partnership. HPE, along with a lot of other companies, look to Accenture as a system integration partner to provide customers with cloud integration services for public cloud giants like AWS and Microsoft Azure. And in addition to that, after the spin merge of HPE's enterprise services business with DXC Technology, the two companies formed a strategic partnership to deliver services for various hardware, such as converged infrastructure, storage, and high-performance compute systems. So benefits of businesses who can utilize this strategy include a lot of increased efficiency, mainly cost benefits, including profit turnaround, because as we know, services are the higher margin offering, and vendors can really have a leg up on the competition by leveraging that financial benefit to remain competitive. And just to kind of conclude this prediction with some more examples of vendors who can meet these shifting customer demands for the one-stop shop model. The most critical example here that we kind of touched upon was the Dell Technologies and VMware relationship. VMware is, as we mentioned, vendor agnostic when it comes to hardware, but Dell EMC has an advantage over competitors given that they're part of the same Dell Technologies umbrella. But on the other hand, this trend will create a lot of fear and uncertainty for other companies who are really reliant on their indirect channel. And we recently saw this with HPE's acquisition of Blue Data. Dell EMC and Blue Data, which is kind of a software company operating around AI and machine learning, they have had a relationship for quite a while, and last November, HPE announced that they intend to acquire them. And given that Dell EMC and HPE are competitors in many regards, this is obviously problematic. But to even further complicate the situation, VMware also has a strategic relationship with Blue Data. So the partner dynamics are really messy, and the outcome of this acquisition is unknown. But it's highly possible that HPE's buyout will cause the Dell EMC relationship with Blue Data to dissolve. And on top of that, more legacy companies that are migrating into the cloud space. NetApp is a great example of a company who quickly transformed from a legacy vendor to cloud. You know, they now have their own cloud business unit that's a year old. But of course, there are risks for these type of companies. They're looking to partner with really niche companies that can help them in gaining that cloud knowledge and market share. But there is the risk that they will be acquired by much larger market leaders, like a Dell EMC, for example. And finally, as we already mentioned, was the IBM Red Hat acquisition, expected to close in the latter half of this year. But there is a lot of speculation around what will happen to Red Hat's existing partnerships. One instance is Oracle could really emphasize their go-to-market strategy and bring to market aggressively Oracle Linux, which is basically Oracle's branded solution of Red Hat's enterprise Linux platform. And that's a really key thing of what IBM is after regarding that pending acquisition. So again, just kind of highlighting some of the partner dynamics there and the critical role that service providers will play in 2019. So I think that concludes our second prediction, and with that, I'll turn it back over to Stephanie.
Okay, thanks, Katie. Those are some great insights. Just want to make sure this slide pops up here. Okay, perfect. So on this slide, I wanted to talk about some of the emerging technologies we're seeing in the data center space. And this prediction focuses on how emerging technologies will reshape customer demands in the IT space. And data management will be at the center of this shift, especially because a lot of the emerging technologies are data-heavy technologies. So the emerging infrastructure technologies will lay the foundation for how companies compute and store data in the future. Use cases like AI and machine learning are causing this rapid data generation, and data infrastructure vendors are tasked with innovating to develop ways to harness the power of this data for their customers. Not only are vendors innovating around emerging technologies to handle the growing data volumes, but vendors are also innovating to enable computing on the edge so that customers can harness the power of their data and do so faster. So this concept of moving the compute to the data instead of the data to the compute will enable these faster insights and has the potential to create greater value out of the data. We think 2019 will see an influx of innovation around edge computing as well as data center infrastructure enhancing capabilities like NVMe and GPUs because customers will increasingly demand infrastructure that facilitates their desired business outcomes. Okay, so quantum computing is clearly an emerging technology, but it sort of falls into its own category as its development will have such a significant impact on computation as we know it. And once quantum computing reaches quantum advantage, we will see an exponential advancement in compute to apply against some of the world's most complex algorithms to solve very challenging business problems. Currently, use cases are expected to initially be seen in verticals like healthcare, science, and banking, but it's likely that the uses will rapidly expand as emerging data-heavy capabilities come to fruition. And given the performance boost quantum has the potential to provide, firms that have not at least built small teams to begin learning the new tools and methodologies available from firms like IBM, which their QuizKit, and Microsoft's Q#, which if you've seen it written looks like Q#, could find themselves at a significant disadvantage once quantum computing reaches that quantum advantage. And while we don't know when the tipping point will be, it is clear that there will be one. And we think it's going to be sooner than a lot of organizations are thinking. And so on the slide that you're looking at right now, we've laid out some of the top players in the quantum computing space. And our research indicates that the biggest bottleneck right now to commercialization is at the engineering level involved with the hardware, because they have to engineer that hardware before they can push these solutions out as a cloud service. But there are many vendors working on the hardware and with different quantum computing theories in mind. And it's too soon to tell which of these theories is going to be the first to really emerge with some large-scale commercial capabilities that both improve on the classical capabilities but can also be done at larger scale. Okay, so once the hardware is established, the myriad of software vendors that are working on quantum algorithms will be able to rapidly monetize their discoveries. But there are significantly more software vendors working on quantum than there are hardware, and there are some vendors working on both. And the majority of the startups in the quantum space tend to be software startups. So in this slide, we are showing the pure plays versus the multi-lines in the space. And it seems to be widely accepted among the quantum computing vendors that the multi-line players currently have an advantage. And that's because the multi-line vendors have additional streams of funding they can access, whereas a pure play would have to continually go around doing funding, which the vendors have vocalized is kind of a distraction from their overall goal to work on the technology. And I just wanted to mention that already in 2019, IBM announced their IBM Q System 1, which is an advancement in this technology, but is, in our mind, it's the first of many in the quantum computing space. And with that, I'd like to turn it over to Geoff.
Okay. Thank you, Stephanie. What I'm about to put up is a rather messy slide. These are what some of the folks here call my Jackson Pollock prints, but this is one where what I'm trying to do is show you both the sort of standard performance development curve of what we've known as classical computing, otherwise known as Moore's Law. The year I use is 2012. So the purple line there is basically what Moore's Law can improve upon, all other things being equal, just the faster, better, cheaper that comes out of the Intel fab plants and AMD and wherever else. The green line was a statement. These 2012 figures came from a briefing I was at an analyst conference where the people were talking about what they were going to be able to do with CMOS innovations over 20 years, and then what happened to them when you added cognitive. So they had a 100,000-fold improvement for Moore's over 20 years, a million-fold improvement or 10 times Moore's when you factored in cognitive on classical. And the last line, that red line that just goes straight up in the air, was from a quantum conference sponsored by Fujitsu Labs in October of 17 where I spoke. And one of the vendors that was there, it was either D-Wave or Rigetti, I honestly cannot recall, stated that an algorithm run on quantum computing ran 1,000,000 times faster than it did on Moore's. So that's 100-fold or 1,000-fold improvement over what we've known for 50 years. And right now, if you think about it, the barrier line is that red line. That is what we can do on classical computing. So this quantum leap, in our performance, is going to hit one algorithm at a time by industry. And it's going to need to be tethered into a multi-cloud instance or a multi-compute instance, because it's only going to be there for the bursting of these very complex applications. This is why the control plane, the multi-cloud manager, I think is the term IBM has. It's integral to why they acquired Red Hat, in order to be the one that does the orchestration and management between that which resides on-prem, that which has been moved to, I'll call it classical computing in the cloud, and that which will lend itself to a quantum processor for those very niche applications or those niche points in the compute process where you need to funnel it over to a much more powerful compute architecture in order to get the insight back. One of the briefings, Stephanie and I have been on a lot of briefings over the last couple of weeks with various vendors in the quantum computing space. I believe it was Nokia Labs that gave us this analogy that in the New World Order, machine learning is sort of the smarter, say smaller sized in stature, physical stature brother, and quantum is the sort of less intelligent big brother, and all MLAI is doing is instructing quantum what to pick up and put down. That without MLAI, quantum really doesn't have the intrinsic value, because you've got to instruct it on what to do. And that's where the algorithm layer comes in and is so critically important. So now, step backwards a little bit to some of the projections they were having around HCI, around the edge. As 5G enablement comes through, the edge will become more of a reality. It's the third leg of the compute, storage, and network stool to virtualize. In theory, once that's virtualized, we will have that North Star objective we've been talking about for decades of utility computing, and plugged into that utility compute will be the cognitive capability when it's needed to be able to burst through these applications. So the issue is right now, and probably a lot of you in the audience are sitting here thinking it's 10 years away, it's too soon, you folks need to lay off the caffeine, it's not here, it's not coming anytime soon. What we have seen through numbers of we do executive level interviews where we'll get a CIO or somebody of that caliber in a Fortune 500 on the phone for an hour to ask questions about various topics. And when it comes to new use cases and new business initiatives, transformation initiatives, we're hearing time and again that things happen faster than they anticipated, with the key thing being if they leave the machine alone to do the learning rather than to go in and tinker with it. If they get the human beings away and let the machine do the learning, it happens faster than they expect. So the rate and pace of change, the competitive advantage window that you'll have if you have the new insight or the new algorithmic breakthrough is going to be shorter. Speed is going to increase. So as we look out to try to say, when can quantum happen, even the people who are doing the research today will say in their briefings it's moving faster than they expect. So this is not to say that there will be a live quantum application that will game change it in fast search or in logistics flow optimizations or air traffic control, any of these places where the language we heard was the traveling salesman's dilemma, where probabilistic outcome and the ability to do it 1,000,000 times faster will get you to a faster decision. If you're in one of those industries where one of your competitors has taken a tiger team and put five or six of their brightest engineers out to be able to develop on QuizKit or Q#, to gain an understanding of how to take advantage of it when it comes along, that red arrow that's shooting straight through the sky could be the arrow of competitive advantage that your competitor gets because they've been keeping an eye on what quantum is doing. They've been laying out the network infrastructure in a multi-cloud environment where the infrastructure is somewhat of the derived decision based on the wrapper of services or the business insights that the GSI has who partners with the infrastructure investment, all those things that Katie was talking about. These different things, if you're not at least looking at the software side and how to integrate it into your existing instances, this could wind up being an extinction event in various markets. I'm going to say within 10 years. I'll say within 5 to 10 years. But there should be some commercial grade applications live on a cloud quantum instance within 3 to 5 years. And we had a question, so let's pull that up. Michael Nelson. Has anyone confirmed quantum error correction above 56 qubits? Michael, I don't know the answer to that. I know the different components I've heard about. There's different approaches to try to solve the error detection. I'm staring at Stephanie Long across the hall. We've been on the briefings, but these were briefings from PhDs in physics, and we have liberal arts degrees, so our retention is limited. What we've been hearing about error correction or what is it? Not entanglement, decoherence. Some of them, if you're just running the probabilistic outcomes, because you're going to run it 1,000,000 times faster, I did have an executive when I pressed them at that conference I referenced that Fujitsu held, and asked them if they were worried about it, and they said they weren't, because in the probabilistic outcome space, if you're running it 1,000,000 times faster, then the law of compensating errors means you're still going to narrow down to the right spot. So there's sort of two answers to your question, and I'm not quite sure if I've necessarily addressed it sufficiently. They are working on that. They are working on the persistence. Ion Trap has a methodology for doing that. The topological folks have a different approach with radio signals. Is that what it is?
Yeah, it was a
radio waves. Radio waves to try to, the way they said it is bend the laws of physics to be able to get a more persistent state. And then on the superconductor side, I honestly don't know what they're doing there other than it's that cooling to slow it down to get rid of the particle interference. Hopefully that gave some answer to your question, but I realize it was a little vague. That really concludes the core of this. We had a couple of questions that came in while we were there. Stephanie, do you have those?
Yeah. So one of the questions we got was, how do you see the AWS outposts impacting the data center space? And so these outposts, they're going to come out in 2019, so their impact is unknown at this time, but we do see that customers are increasingly putting workloads on-premise and in the public cloud. Security is one of the drivers behind keeping things on-premise, and the outposts do provide AWS customers with a little continuity with the underlying infrastructure of their cloud environments, whether it be public, private, hybrid, what have you. So it is possible that that customers take to that strategy and pursue the outposts from AWS, which would be to the detriment of some of the hardware players. But that's our prediction for that. It remains to be seen what will actually happen in that space.
This is Geoff. I think it's a fascinating development from the sense that AWS, in theory, was taking away finished good end product sales from the traditional OEM manufacturers. Now they're turning around and they are able to at least get, shall we say, increased discounts based on increased volumes for that which they're developing for internal consumption and be able to sell it back to their large cloud instances. So this idea that hardware increasingly becomes a derived decision to the services wrapper, and if you are all in on the AWS control planes and orchestration layers for data management and everything else that they're doing, this is almost, it's the axis flipping. And therefore, because of the services value and the integration value, we might as well use this hardware over somebody else's because it easily integrates into the overall instance. So they're coming at it as a way, the value is in their control plane. That is somewhat the IBM Red Hat play against where, in theory, IBM doesn't have a private label industry standard server to populate, that they will try to come in and take that services layer and just leave the pure iron sale to those who are looking at iron as a need to be attached to wraparound services. IBM Red Hat's coming at it for the services, and AWS is coming in not only with the services, but as a way to gain a lower average unit cost for the iron that they're going to consume internal building out their data centers, as well as be able to tie it in. Okay, we have...
I can answer this question. Are the slides available for download? We don't put the slides up for download, but you can access the replay, which will have the slides in them.
Okay, we had a question. Azure Stack and Outpost are taking a very different hardware approach, OEM versus ODM, Amazon Hyperscale. Thoughts on performance of these systems? Interesting point. I think of Outposts, as we just said a little bit, is more of that. It's a logical extension or incremental revenue to AWS that's also strategic in terms of being able to box out some of the other compute competitors, hardware compute competitors, in order to get more of a land grab on the private side of the shop for AWS. Azure Stack has the ability to run, again, it's sort of a similar game, but Microsoft is not getting into the hardware business per se. So they will allow for those optimizations. What is unclear is Microsoft is doing a lot of development work around quantum, and in that regard, they could very well be looking to set up the quantum, their own sort of quantum cloud equivalent, which is the way, that's the IBM play. They're making it very clear that's their play. Microsoft isn't being as overt about it, but they are investing in the research and development of quantum capability. So the logical inference is they would come out with something similar, I think, is the way that I would say that.
Okay, this one is for Geoff as well. How do you see the edge changing how enterprise IT deploys their hardware?
The analogy I use, run the performance curve. The smartphone I'm playing with on the table here is the equivalent of about the power of 1,000 servers from 20 years ago. So now think of a hyperconverged box. That hyperconverged box is probably the size of the dorm room type of refrigerator that, if you're my age, you were buying for your kids when they went off to college. That's where it sits today. But 10 years from now, that same kind of HCI edge compute performance will be in something that is the equivalent of what I'll call the cable network provider's set-top box that you brought in when you subscribe to cable when you move into a new home or apartment or wherever you go. So from the edge perspective, it will become that derived decision. You'll be looking at the software value or whatever it is you're doing. You don't choose your cable provider based on what set-top box manufacturer they use. You don't even know. You just wait for them to plug it in for you. So HCI is going to get down to that level of automated technical simplicity to be populated anywhere. Now, the change with that, with 5G coming in, so you have the tighter transmission layers, is the threat is more to the colos, like the Equinixes and the Digital Realties, where they have they're building out the major, for lack of a better word, not to oversimplify what they do, but the large sort of physical warehouse places where you then rent the space to plug in your gear. That's going to wind up being something that in theory would have to be ruggedized for outdoor climates and everything else, and will be like those transport stations the network carriers have. So the real estate play will be who owns the tower. And underneath the tower, can we install an HCI box for the aggregation and transmission back to the central offices or where these things need to go for the compute to get all the data in one place to apply the application against it. HCI and the edge will also be there where real-time inference is important. The example, the use case we've heard the most in our discussions on that would be, say, airport security, and you have me listed as an unfriendly, and I go in, and then I go into a bathroom and I change my disguise, or I put on a beard or whatever, is to be able to have that real-time inference that can say, a man went in wearing a blue suit, he came out wearing a check shirt and had a beard, but it looks like it's the same person, go get him. That type of inference that compute will have to be done at the edge. So the edge has two different things, the aggregating mechanism to then put the security wrapper on it and shoot it to where it needs to go, or to have the AI algorithm in real time taking a look, mapping and doing the inference to make the real-time decisions. Hopefully that helped. What do we have here? The hypercloud scales, space and compute, Who will want FPGA hardware? FPGAs fascinate me. I don't know if I know everything about them. I think I can certainly say I don't. But the FPGA, really what's going on is distributed computing at the chip level. All those things, when I was in my 20s that I was helping wire up under raised floors, is the engineering schematic and the engineering challenges due to miniaturization of electronics that Intel, ADM, Samsung, and all the rest are innovating around to be able to do it in 10 nanometer and 7 nanometer form factors. So in that case, the FPGA can become the analogy I have, and it could be totally off base, but in my head, the analogy is when you needed to download the software printer driver to your Intel 8286, 8386 chip before you could get the printer to work. Now think of it as the workload instruction set that gets landed onto the FPGA to tell that distributed computing on a chip how to perform, how to allocate compute, where to store, what to pull, when, and where. That FPGA could almost become the front end of that as you're dropping it into whatever instance to give the instruction set for the underlying hardware. I think FPGAs are a critical differentiator as the configuration lock that we had. You had Intel servers or blades. That was pretty much it. As you now get down to, I'll call it specialty HCI devices, set-top boxes, with different temperature requirements, different workload requirements, optimized by the workload, and you'll be pushing them in and out and around, or you'll have it as the front end in your own exascale cloud, so as you see the request coming in, you'll know where to load it based on the FPGA that you have on whatever set instance to run SAP HANA SAP HANA workloads versus something else. So another question. Are SLAs in play with AWS Outposts? I honestly don't know the answer to that. The individual who asked that question, we will get an email back to you. We want to check with Megan. Megan McGrath is our Amazon analyst. We'll want to talk with Megan and see what she knows about that. But we will communicate back to the individual who asked that question with whatever we, TBR, know about that. Well, we seem to have finished up with the questions. I don't know if there are any others that are there. We did kind of take a fire hose approach in that last slide as to what we see and where we see it going. The quantum play, to just sort of summarize it, there is the piece, the known knowns. If you want to know where quantum will go, at least from the old world view, just take a look at where Cray was selling their supercompute boxes in the 70s, 80s, 90s, and aughts. The flip side is all the new, where the FANGs play. That's where rapid search, there's clearly something for that. There's logistics optimization. All these things based on sensors that we have. The more sensors we can put out through IoT and the edge, the more data we have for quantum to pick up and put down as instructed by an analytics algorithm. and it's going to hit one algorithm at a time, and who knows what we will find, what the unknown unknowns are that quantum is going to be able to solve for us, and hopefully solve some of the persistent questions we have that are somewhat troubling to us today, such as climate change being, a principal one among us, human genomic research, medical research, scientific research around the climate. Those are certainly two positive places where this compute power will certainly make our world a better place, and it's going to be exciting to see that roll out over as I said, probably nothing earth-shattering within 5 years, but boy, after about 10 years, I expect to see some things hit there. Any other, you want to wrap this up, Stephanie?
All right, everyone. Please feel free to reach out to the team or send an email to webinars@tbri.com with any follow-up questions. If you have a few moments, we would appreciate if you could fill out the survey on your screen. A replay version of the webcast will be available after the event and will be sent out to you via email. To view a list of our upcoming and past webinars, please visit tbri.com. Be sure to join us on Wednesday, February 13th for 5G will be an evolution, not a revolution. Thank you and have a great day.